All right, Algebra 1, this is 7.3 in your book, page 444. This is my favorite way to solve linear systems. Okay, so systems of linear equations, two or more equations with the same variables. Okay, so solving linear systems by elimination. So first off, let's write these again and I'll show you. We'll go through it. You add or subtract the equations to eliminate one variable. It's supposed to be a 1 over there, not on. One variable. Solve the resulting equation for the other variable. Substitute in either original equation to find the value of the eliminated variable. Now I know that doesn't mean anything, but let's do one and I'll show you. So you take the two equations and you stack them on top of each other, lining up the x's and the y's, and you look and you see if one of them can be eliminated, meaning one is a positive and one is a negative, and these two are. So those can be eliminated, and then you just add. This is just combining them together. So we're just going to add. So 3y plus 5y is 8y, and that equals 24. Divide by 8, y equals 3. So we found y. Now you go back up and you pick one of the equations. So let's just pick that top one. 2x plus 3y equals 11. Put in 3 right here, so it's 2x plus 9 equals 11 minus 9. 2x equals 2. Divide by 2, x equals 1. So your answer is 1, 3. Still involves algebra, but I think it's much quicker. At least this one worked out because it was all set up for us to eliminate. But I'll show you what happens. We'll keep doing these. So let me show you what we did. Add or subtract the equations to eliminate the variable. So right here we added because a positive and a negative canceled each other out. Okay? And then solve the resulting equation for the other variable. So we added and we solved what was left for y. And then substitute in either of the original ones. So we picked one of them and we put in what we got. There it was. So this is them doing the same thing. Substituted it in, solved it, and found that x was 1. Okay, and then you can always check to see if it works in both of them. And especially if it works in both of them, then you know you got it right. You should never miss these. You should always take the time to check these. Alright, so check this one out. It says use addition or subtraction. This time my y's, look at my y's, 3y and 3y. If I add them, I would get 6y. But if I subtract them, I'm going to get they're going to cancel each other out. So if I subtract these, I also have to subtract everything here. So 4 minus 5x is negative x. These cancel out. 2 minus negative 2 is positive 4. So x in this case would equal negative 4. So that's tricky right there, that minusing. You might want to go through and put signs on all of those. A lot of times I'll just go through and change the signs and then add them. It's the same thing. Remember, adding the opposite. So you can always go through and boom, boom everything and be ready to go. Then let's put in negative 4. Let's just use that top one. So I'm going to get negative 16 plus 3y equals 2. Add 16. 3y equals 18. Divide by 3. Y equals 6. So it's negative 4, 6. Let's see if they agree with me. Yep, they did. And again, you want to check your work, so you're going to put them in. Okay? They didn't do that on there, but that is the solution. All right, so check this one out. The problem with this one is in order to add or subtract them, you have to pile the like terms on top of each other, and this is all messed up. So you need to get the x and the y on the same side. Notice on the first one, on this equation, the x and the y are on the left side. So let's do the same thing here. So let's minus 3x from this side, minus 3x from this side. So we get 8x minus 4y equals negative 4. Then we're going to get negative 3x plus 4y equals 14. Okay, so these are opposite, so we can just add them. 8x minus 3x is 5x. Negative 4, that makes 10, so x equals 2. So let's just put it into that original one. 16 minus 4y equals negative 4. I put it in right here. I put a 2 in right there. Minus 16, negative 4y equals negative 20. Divide by negative 4y equals positive 5. So 2, 5 is my answer. And that's just rewriting just what I did. And then the solving. So it takes a little bit of time, a little bit of room, but not too bad. All right, so we look at these and we see these are already opposite of each other, so we can just add them. These are going to cancel. So 4x plus, we're just adding these, plus negative 2y, we're combining them, is 2x. And 5 and negative 2 make negative 5 and negative 7, make negative 2. Divide by 2, x equals negative 1. We'll put it into this top one up here. We'll put a negative 1 in right here. So negative 4 minus 3y equals 5. Add 4, negative 3y equals 9. Divide by negative 3, y equals negative 3. So negative 1, negative 3 is my answer. These are again opposite, so we can add those, cancel out. Negative 6, make sure you keep the signs with it. Negative 6 plus 2 is negative 4y equals 12. Divide by negative 4, y equals negative 3. I'm going to put it in for the second one. 2 times negative 3 is negative 6 equals 4 plus 6 plus 6. 5x equals 10, so x equals 2. So write that. 2, negative 3 is your final answer. That's it. These are opposites, which is great. 6x minus 3, or plus a negative 3 is 3x equals 15. X equals 5. So let's put it into that top one. 30 minus 4y equals 14. Minus 30, negative 4y equals negative 16. Divide by negative 4, y equals positive 4. So 5, 4 is the answer. Now this one, these aren't, there's 7, those won't cancel out. So we're going to subtract. So when we minus everything, it'd be boom, 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 boom. It changes the sign of everything. So those cancel out. It's just going to be y equals 1. And 7x minus 2 equals 5 plus 2. 7x equals 7. X is going to be 1. So I'm getting 1, 1. There we go. This one's not arranged right, so let's move this over here. So we'll minus 3x minus 3x. So we'll get 3x plus 4y equals negative 6. We'll get negative 3x plus 2y equals positive 6. Those cancel out. 6y equals 0. So if y is 0, divide by 3x is negative 2. So negative 2, 0 is the answer. See, it's just, this is so much easier to me to do these. So again, let's move that over there. So 2x plus 5y equals 12 minus 4x minus, so negative 4x plus 5y equals 6. Now we can't add these because these are the same, so I'm going to subtract and I'm going to boom, boom, everything, change these to the opposite. And just boom, 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 because there's 3 different terms. So that's going to be 6x. Those cancel out, equals 6. X equals 1. Let's put 1 in right here. So 2 plus 5y equals 12, minus 2 minus 2, 5y equals 10, divide by 5, y equals 2. So 1, 2. Okay, example 4. During a kayaking trip, a kayaker travels 12 miles upstream against the current and 12 miles downstream with the current as shown. The speed of the current remained constant during the trip. Find the average speed of the kayak in still water and the speed of the current. Okay, so we got two equations that we're going to write right here for this kayaker. The kayaker is going upstream and downstream. So here's the deal. Before we have distance and rate and all this, we need to remember that distance equals rate times time. Okay, so how far is the kayaker going? Did it say 12 miles? So let's do one for upstream and let's do one for downstream. Okay, so the distance is 12 on both of them. Okay, the time upstream is 3 hours, so the rate times 3. This one, the rate times 2 going downstream. Right? So if we solve this one, divide by 3, his rate is 4 miles per hour going upstream. His rate is 6 miles per hour going downstream. This is up. Okay, so we are supposed to find the average speed of the kayak in still water and the speed of the current. Okay? So together, wow. Okay, so this is where we got ours. Let x be the average speed of the kayaker in still water. Let y be the speed of the current. Okay, so upstream, the current, it's against him, so x minus y equals, and he was going, what, 4 miles per hour upstream. Downstream, it's helping him, so x minus y equals, or x plus y equals 6 because it's helping him go downstream. The x's cancel out. 2x equals 10. X equals 5. 5 minus 1 is 4 equals 1. Y equals 1. So in still water, the kayaker is going 5 miles per hour, and with the current, it's 1 mile per hour. So obviously with the current, you're going against the current, you're going slower. So we'll see, let's see what they did. There we go, there's our x minus y, there's our plus, solving the system, there's the 5, and then there's our 1. Suppose it takes a kayaker 5 hours to travel 10 miles upstream and 2 hours to travel downstream. The speed of the current remains constant during the trip. Find the average. So it's the same thing. So 5 hours to travel upstream 10 miles. So upstream, they're going 2 miles per hour. Downstream, they're going 5 miles per hour. The speed of the current remains constant, so x minus y equals 2, x plus y equals 5. Cancel out 2x equals 7, divide by 2, x equals 3.5. 3.5 minus 1.5 equals the 2, or plus equals 5. Let's see how we did. There we go, yep. And all I did was use what I learned from that last example. So, all right, so you're combining equations, and I hope you see they're easier. I hope they're easier for you guys. If not, please ask, and I'll be happy to help you. This is tough stuff. So, all right, we'll see you next time.